Let's take a look at what we mean by the rate of reaction and how we can express that rate of reaction mathematically. As an example, let's look at the destruction of ozone in the stratosphere, which sometimes occurs with an oxygen radical. Remember that a rate is how fast something changes in time. In this case, since we're looking at a reaction rate, we're looking at how fast the concentrations change with time. If I look at the stoichiometry of this overall reaction, I notice that the oxygen radicals and the ozone molecules are going to decrease in time, and the oxygen molecule is going to increase in time. Furthermore, every time I lose one oxygen radical or one ozone molecule, I make two oxygen molecules. And so the oxygen molecules are going to appear twice as fast as either the ozone or the oxygen radicals disappear. So if I look at the appearance of the oxygen molecules, I'm going to measure a rate which is twice as fast as if I look at the disappearance of the ozone. So which one is the rate of reaction? To solve this problem, we're going to define the unique rate of reaction, or the velocity of the reaction, as equal to 1 over the stoichiometric coefficient times the rate of appearance or disappearance of that particular component in the reaction. Remember that stoichiometric coefficients are positive for products and negative for reactants. And so the unique rate of reaction for this ozone destruction reaction is minus the derivative of the oxygen radical in time, which is equal to the opposite of the derivative of the ozone in time, which is equal to 1/2 the derivative of the oxygen concentration in time. Notice that the derivative for the reactants are negative and the derivative for the products are positive. This is because we want the rate to always be a positive number, and the concentration of the reactants decrease as time increasing, making this derivative negative. Thus, we need the opposite, the negative, to make the rate positive. Since the products increase concentration in increasing time, this derivative will naturally be positive, and so we report the rate as the positive change in the product concentrations with time.